Hi everyone, I'm Justin Enda from Mixel, and today we'll be showing you a demo developed in collaboration with our partners and fellow MIPI Alliance members, Hardent and Rambus. The demo showcases an integrated display IP subsystem solution that combines the Mixel MIPI C-PHY D-PHY combo IP, the Rambus MIPI DSI-2 host controller, and the Hardent VESA display stream compression, or DSC IP. This complete solution targets next-generation display applications requiring high bandwidth and excellent power efficiency for mobile, AR, VR, and automotive. Now let's get started by first taking a look at the different blocks that make up the MIPI DSI-2 and VESA DSC IP subsystem. The subsystem is designed to enable video transmission over the Mixel C-PHY D-PHY combo and includes support for the VESA DSC compression over MIPI DSI-2 transport. The subsystem is made up of a dual-channel MIPI DSI-2 transmitter with DSC compression, including the Hardent DSC version 1.28 encoder IP, the Rambus DSI-2 host controller with 1 or 2 instances, and the Mixel MIPI C-PHY D-PHY combo IP with 1 or 2 instances. It offers uncompressed and DSC compressed video transmission supported across 1 or 2 links and supports both asynchronous pixel source from DMA or synchronous pixel source parallel video. This block diagram shows the host IP subsystem, and we'll be using this as our example during the demo. A peripheral version of the subsystem is also available. Our demo today, you will see an FPGA-based implementation developed to demonstrate the IP subsystem. Here we have a system diagram showing the different hardware components, as well as the data paths and modules inside the FPGA design. The objective of this demo is to demonstrate that our integrated solution can drive a display with a DSI-2 interface and leverage the industry standard DSC decompression to reduce the bandwidth required on a single link. We have chosen an AR/VR type of display from display panel maker BOE. It supports 1440 by 1600 resolution, up to a 90 Hz refresh rate, and a DSC decoding of a video stream compressed at a 3x ratio. You can see the display here on the right. On the left, a laptop with a DisplayPort output is used as the source to provide an uncompressed display stream running at 1440 by 1600 by 90 Hz. The DP cable is then connected to an Enrevium DP daughter card, which interfaces between the laptop and the high-tech global carrier board, which you see here in red in the block diagram. The DisplayPort stream is converted to a parallel pixel data using a Xilinx DisplayPort IP subsystem. After this, the video is extracted. It then goes to a frame buffer and into an external DDR memory. The frame buffer is primarily used as a time-based corrector or frame rate converter, if required, to test various display frame rates. Then a video DMA will feed the Mixel Rambus Hardent MIPI DSI-2 VESA DSC subsystem, shown in the box outlined by the black dashed line. 2 of the subsystem components are inside the FPGA, the Hardent DSC encoder that compresses the video into a DSC stream, and the Rambus DSI-2 host controller. For the Mixel PHY, an external test chip is used. The Mixel C-PHY D-PHY test chip is on a daughter card connected to the carrier board. In this particular demo, the final output of the subsystem is a fully compliant DSI-2 1.3 stream operating in video burst mode and transmitted in D-PHY mode with 4 data lanes running at 500 megabits per second plus the clock lane. Finally, an adaptation board developed by Hardent allows the DSI-2 link to reach the panel through a flat cable and provides power to the display. Now that you've seen what's inside the demo, let's take a look at the demo itself. As I mentioned, the video is coming from the laptop and enters the board through this green card. The FPGA that comprises the Hardent DSC encoder and Rambus DSI-2 host controller is located underneath this heatsink. The Mixel IC test chip is underneath the display panel in the adaptation board. As you can see, the display panel plays in real time at 90 Hz, the video that was received DSC compressed at a 3-to-1 ratio through a fully DSI-compliant interface. Now that you have seen the demo, let's take a look at a real-world use case where the subsystem could be used. Many commercially available VR gaming products require a tethered connection to a computer using a DisplayPort cable, and a conversion to the MIPI DSI-2 standard occurs in an embedded IC present in the HMD or the head-mounted display, prior to driving the display panels with a short-range interface. The use of VESA DSC compression technology for this type of application allows you to reduce the required DSI bandwidth by up to 3.75 times for 10-bit HDR content and/or enable higher resolutions and frame rates. All this while preserving visually lossless picture quality. In our demo, DSC allowed us to lower the DSI link rate down to 0.5 gigabits per second, which greatly reduced the power and EMI, while achieving the maximum frame rate of 90 Hz that the display can support. Mixel Rambus Hardent subsystem solution supports a variety of configurations and operating modes that enable ASIC IC designers to find the best trade-off between design area, design complexity, DSI link bandwidth, power consumption, and EMI. Whether it is for an AR or VR application like this one, a mobile application, or even an automotive application, the DSI-2 VESA DSC Host subsystem can be tailored to meet the requirements of these different end products. To summarize, there are many benefits to using this integrated display IP subsystem. These IPs have been adapted and tightly integrated together to render the best possible solution for anyone wishing to develop next-generation display applications using a combination of MIPI DSI transport and VESA DSC compression. This IP solution enables our customers to lower project risk with a fully integrated and verified IP subsystem and accelerate ASIC and SoC time to market. It also offers maximized functionality and availability of all MIPI DSI-2 operating modes and is optimized for ASIC design performance. Mixel has worked with Rambus for over 10 years, and we have a solid shared MIPI experience as founding members of Mixel's MIPI Central, an ecosystem partnership of MIPI stakeholders across the supply chain. As display bandwidth needs increased, we started to receive more and more requests for DSC as a part of DSI-2 deployments. And since Rambus has had a strong working relationship with Hardent for several years, it was a natural next step for us to introduce a combined solution with all three companies. We announced Hardent's participation in Mixel MIPI Central late last year, and we have hit the ground running on multiple projects since then, including this demo that we're seeing today. We all have domain experience and can work seamlessly together on your next project. Thank you for watching our demo today. For more information about this IP subsystem, stop by the Mixel booth during MIPI DevCon or contact Mixel, Rambus, or Hardent. And if you missed our presentation earlier, it will be available on demand after the event. Thanks.